Okay. So before I start making the announcements, does anyone have any question about anything? Yeah. Yes?
We still have time to do the makeup quiz for.
So what about quiz 4?
Well, if we do the makeup quiz for quiz 4, we have until 5 p.m. tonight to submit that.
Yes, so this is one of the announcements that I'm going to make, that I extended all the extra assignments, all the makeup quizzes, everything that you didn't turn in, you have until 11:59 p.m. tonight. But after that, I really need a week to do all the grading, and then some of you see that I'm behind grading because of all the makeup exams, all the makeup quizzes, all the things, so it just delayed me, so I need a week. So you have until 11:59 p.m. tonight. So the other question? Anyone else had a question here? No? Okay. So, yes.
What if you haven't gotten your
What's that?
What if you haven't gotten your quiz 4 back yet?
So I graded half of them. Again, I was really busy this week with all the makeup exams. So some of you might not know because you're not taking the makeup exams, but there are students that they come from like 2:30 to like 5 or like 6 to tonight. I have a student that is taking the exam at 5. So I have to proctor those exams, and I cannot quite grade quizzes when I'm doing that. So hopefully during the weekend, I grade all the quizzes, makeup quizzes, and then next week, I grade all the extra credit assignments, post them on BBLearn. So if you hand me a solution during the class and I forgot that, you have the time to tell me. So yes, I'll catch up with all the grading. And if you know that you didn't hand in your solutions with your quiz 3 or quiz 4, just take a makeup quiz and send me your solutions, because I'm not going to grade them if you didn't give me solutions. You see why I'm doing that, right? Because it's a Scantron. I have, or some students might just like fill out the, Scantron without doing the quiz. So that's why I need the solutions to make sure you did that yourself. Any other question about the quizzes, extra credit assignments? Okay, so again, I'm emphasizing that your makeup exam, or not makeup exam, your final exam is next Friday, which would be December 17th, and it's at 10:15 a.m. And as I said, if you have conflicts, if you have 2 exams on a day, if you're like traveling home, you cannot make it, you are welcome to take it sooner. But after this date, if you miss it, you will miss like 200 points. Your exam is out of 200. And I give you 50 questions, each 4 points. And you have 2 hours. And as you saw in your previous exams, there are lots of them conceptual problems, so the time would be more than enough. Any question about that? So, during the previous exam, I was told by my TAs that some students were looking at other people's Scantrons, and as you know, or as you may guess, it's really hard for me to accuse people that they look at other people's Scantrons, because, sometimes myself, when I'm taking a test, I cannot just be like this all the time. I need to rest my neck, So I cannot, and then we have a small room, considering we have 250 students. So I cannot, anyone that, looks up or looks around, I cannot tell them that, oh, you're looking at the other person's Scantron, right? So if you, I heard from my TA that some students have concerns that some other students might have looked at their Scantron. So if that's the case, try to kind of don't put it so open for everyone to see if you have concerns. And to prevent any cheating, I'm going to have 4 versions of your final exam. They would be all similar, so the level of difficulty is not higher or lower. They are all equally, the level of difficulty is the same. And I will give you the Scantron. Don't bring any piece of paper, anything to your final exam. Just a pen, pencil, eraser, stationery, anything that you want to answer the questions with, and a calculator. other than that, if I see a piece of paper, I assume you wrote something on that. So don't do that. And I had 2 students on their exam 4, they wrote electronic configuration on their Scantron. And that is really odd because, and then they erased that. And then I looked at the questions, the electron configuration, and they had it wrong. So I was like, okay, so I'm not going to do anything about it. But for like future exams, you know that when you have like a Scantron, you're not supposed to write anything on it. Because, you know, even if you write it during the test, you might have written it at home, right? Because you brought the Scantron. So to prevent all the confusion, all the concerns that some students might be cheating, so eliminate all of that, and I don't have to worry about watching you know, 24/7, who is looking where. I'm going to have 4 versions of the final exam. So, you know, and you know, in that case, it would be obvious if I see in a Scantron of exam, you know, the version 1, I see that it's equivalent to version 4, I know that probably you were looking, especially I have like so many questions, true or false, that they are only A or B. So if I see for multiple one, you answer D or C, I know that's probably you're not work. And that is the last thing that you want to have, right? Because if you cheat during the test, that would be automatically failure in this course. But with all the extra credit assignments, everything that I'm doing, you can easily pass the course and also get A or B. So don't do that. Just don't think about it. That I'm going to have all the notes, I'm going to coordinate with my friend, I'm going to sit next to them, I'm going to look at, you know, that's not going to work. There are like 4 versions. You know, the person next to you, in front of you, the other person in front of you, they have all different tests, so it's not going to work. Any question about anything that I just said about makeup, about final exam, you know, versions, different things? Okay, so as you saw during the past month and a half almost, I've been assigning extra credits. And to have you familiarize with your final exam and also give you even more extra credits, I designed a practice exam in BBLearn. And if you log in now, you can see that. I also wanted to show you that, but now I'm short on time, so I'm not going to do that. But if you log in, you can see the practice test. You can only take that test 1 time. It's exactly the same structure. 50 questions, there are each 2 points is out of 100. Your final exam would be out of 200. Each question would worth like 4 points. But other than that, it's the same structure. 10 questions from chapter 1 and 2, 10 questions from chapter 3 and 4, 10 questions 5 and 6, 10 questions 7 and 8, 10 questions 9 and 10. So the exam is timed. You have like 120 minutes, like your final exam, but you can answer 2 questions, close it, come back to it. But you cannot go back to the previous question. Does that make sense? And I know that, you know, probably some of you will look at the solutions or your notes. So to make it towards all the students, you are welcome to use anything that you want. Your notes, class lectures. Remember that the exam is timed. So when you start taking the test, you should kind of like watch out for time, right? But other than that, you can, you know, and the main source that I encourage you to refer to is your study guides. All the conceptual problems are from study guides. And even for chapter 7, 9, 8, some parts I even highlighted, right? So study them well. Nothing is out of the study guides for conceptual problems. And for chapters 1, 2, 3, 4, and 10, I am only going to ask from the study guides. So if you study those, you can get at least 50 out of 100. And for the other chapters, as you saw, most of the problems are also conceptual. So if you even if you don't know any math, even if you don't know what is 2 multiplied by 2, you can study the study guides and at least get between 75 and 80 between B and C on your final test. So don't be discouraged if you don't know what is mole, if you don't know what is conversion factor. I encourage you to study those, but What I'm saying is that you still can get a really good grade up to B on your final exam just by studying the study guides. Yes?
Could you say again which chapters you're taking the conceptual questions from, the study guides?
So all of the chapters, I will ask you about conceptual problems too. And you saw in your makeup exams and in your exams that what is stoichiometry? Or like when we had the cooking recipe, what is stoichiometry? Or like what is recipe correspond to? And some students were saying chemical formula is like stoichiometry. So all the chapters, even if they are like dense with problems, you know, kind of like chapter 6, I still will ask you conceptual problems too. But chapters 1, 2, 3, 4, 10 are merely exclusively from the study guides. You don't see, you know, all the chemical structures that I'm going to ask in final, I'm going to write in final in the study guide. So I won't ask you like what is the structure of glucose, you know, something that I didn't teach in the course. Everything you see for chapters 1, 2, 3, 4, and 10. Everything is on the study guides. For other chapters, you also have problem solving, you know, and quantitative problems. So I can not only ask from study guides, but still, if you study the study guides, you can get like lots of the problems, right? Okay, and so this is about the practice exam on BB Learn. And imagine you took the test and then you got like 80. So you get like 80 on practice exam. I'm going to add this 80 to your final 800 and other extra credits. So it's almost, you know, with all this, you know, extra credits and this exam, you'll have up to 2 letter grades. That if you got C, now you can get an A. So I did that to encourage all of you to study well, you know, and as I was saying to students that they were coming to my office hours, and some of you, you know, you may know that, as long as you care about this course, you will get a good grade. As long as you do the extra credit assignments, study the study guides, and then do your best. But, you know, I will add anything that, so if you just, you know, ran, you know, like at Wednesday night, you know, you decide to take the practice test and then you just by chance answer the questions and then you get like 5 or 10, I'm just going to add 10 points to your 800 points. Does that make sense? So try to do your best on this test. This is really similar to your final exam. And the other thing is that I will post all the solutions to extra credits, all the makeup exams. You know, I have like 2 versions of makeup exams. I have 2 versions of makeup exams for each exam that you took. So you'll be having so many questions. I will adding the, you know, posting the solutions. So I encourage all of you to study them because it will really suck if you realize that 70 questions, or not 70, like 40 questions out of 50 were from makeup exams. And you could have gotten an A if you would study those, right? So study everything that I post on BB Learn, just study them really well. You might see them in your final exam. And I will post all of them. And also for your, Mia asked me this question last session about the extra credit assignments that you did on BB Learn, multiple choice questions. If you did them already, please don't go back to them and don't redo them because the deadline for all of them are tonight and I don't want to mess up the grades. So I will post all the solutions tomorrow, so just refer to their solutions that I will post to study them for your exam. Does that make sense? Any question about anything that I just said? Yes?
Is that going to be posted right here, the test, like with the rest of the
You should be able to already see that. You don't see it?
I don't see that.
Okay, I will check to see what is up. But yes, you will see that, you know, and it will say like practice exam, 100 extra credits. So you will see that, yes.
When will that practice exam close on the
Really good thing, good question. I just wanted to say, but I was just like, got busy. So the deadline for practice exam is 5 p.m. the night before the exam, which is Thursday, December 16th. And the reason is that I'm going to post its solution. So you have like few hours that night and then few hours, couple of hours depending on when you wake up in the morning to study the solutions. So that's why the deadline is the night before at 5 p.m. And after that, you won't see the exam anymore. But I will post the solutions on the website, so I'll make sure that you know those solutions. Does that make sense? Okay. So the other thing, student evaluations. I also sent BB Learn announcement about it. I really encourage you all to take it because based on the results that I saw this semester, I may change some structures from the course, like make, for instance, attendance mandatory, maybe not posting the lectures online, and then just make them available for students who reach out to me. So I'm just thinking of ways to change the course. So if you saw something that you liked, please give me feedback so I know it was helpful. Like if you liked extra credit assignments, if you liked seeing lectures online, if you liked makeup exams, right? So anything that you liked or anything that you didn't like, please tell me so I can work on myself and then on the materials to make the course better, okay? And the deadline for the evaluations is tonight at 11:59 p.m. too. So if you have the time, focus on your extra credit assignments. But I highly ask you, or kindly ask you to do that so I can do better next semester. And some of you might have carbon compounds, you will see me next semester, so I can use your feedback to try to do better next semester. Okay, any question about anything? I know that, any time that I come to the class, I have so many things to announce, and I send so many announcements on BB Learn too. But still, when I come out of the class, I remember, oh, I forgot to tell this. So if you can think of anything that I didn't mention, just let me know. Very good? Okay. So now I'm going to finish as much as I can from chapter 10. And as I said, chapter 10, I only asked from a study guide. I'm not going to be able to finish the chapter, but I try to teach you as much as I can so that you learn. And as you may have noticed, I didn't cover chapter 11 because I rather you have 10 chapters, learn them, compared to having more chapters if you wouldn't learn them. Does that make sense? So now, can anyone tell me how would we define the valence electrons of oxygen? If I just ask you, without writing the electron configuration, tell me how many valence electrons oxygen has. How would you say that? What's that?
6.
Yes, how did you say that? Exactly. So if you go, to the periodic table, so probably, you cannot see it well, but you get the idea that if you go to the periodic table and then you have groups 1A, 2A, 3B, 4B, and then 3A. And this is something that I asked you in your practice exams, that we have main group elements that we have specified them with the letter and a number. 1A, letter A, basically. 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. These are main group elements, and we have the ones that they have letter B with a number 3B, 4B, till 2B, 1B, and so forth. So those are transition elements or transition metals. So in Lewis structures, or Lewis model in general, we only deal with main group elements. So you don't have to worry about transition elements. So for main group elements, if we just look at the group number, that is the number of valence electrons. So for instance, noble gases, can anyone tell me what is their group number? Exactly, 8A, right? So, and there's another way of naming the groups from 1 to 18 too, so some say like 18, some say like 8A. In this course, we're using the ones that has like letter and the number. So 8A elements that are like noble gases, they have like 8 electrons in their valence shell. So what about halogens? What is the number of their valence electrons? 7. Great. What about oxygen, sulfur? What about nitrogen, phosphorus? Carbon, silicon? Boron, aluminum? What about alkaline earth metals? What about alkali metals? Great. So now if you know that, and as you know, in your exam for sure I'm going to give you periodic table and polyatomic ions. And depending on the question that I'm asking from the solubility table, you know, I may or may not give you the table. You should know lithium, sodium, potassium, ammonium, nitrate, acetate. They are always soluble. They're compounds that they form, right? And if I could remember that, you can, believe me. You have much better memory than I have. I won't expect you to know anything if I don't know it. So whether I ask just from those, or I'll give you the solubility table, so don't worry about that. But you should know the ones that I just mentioned, that they are always soluble. So the point being that I'll give you the periodic table, so you don't have to worry about that. In last session, we learned Lewis structures for ionic compounds. This session, I'm going to talk about section 10.4, covalent Lewis structures. And as we know, electrons shared. The other thing I asked you in practice exam, and I'm going to ask in your final exam for sure too, is the difference between ionic bond and covalent bond. This is kind of like one of the main concepts in chemistry, so I expect all of you to know that. So what is the difference between covalent bond and ionic bond?
Ionic is transferring electrons and covalent is sharing.
Exactly. So for instance, in sodium chloride, so this is like ionic, like sodium chloride, you know, so we have Na plus Cl minus. Sodium lost an electron, chlorine got an electron, and what would be the name of Cl minus? Can anyone tell me? So Cl is chlorine. What is Cl minus? Chloride, right? You add IDE at the end of it, right? That's why we say sodium chloride. But for instance, molecular, do you remember H2O? And do you remember how we distinguished in chapter 5 between molecular compounds and ionic compounds? So ionic compounds, they have like ionic bonds. Molecular compounds, they have covalent bonds. So molecular compounds have covalent bonds. So remember, transfer of electrons leads to ionic bonds, and then sharing electrons leads to covalent bonds. So now let's try to have the Lewis structure of H2O. So if you want to write a Lewis structure for hydrogen, how many dots would you put? 1, right? Hydrogen is only have 1 electron, and that is its valence electron. So what about oxygen? How many valence electrons it has? 6, right? So what you do is that you say 1, 2, 3, 4, 5, 6, and you can put the dots anywhere you want, but as we said, we put them in this book. This is how we do it. We fill them singly first and then pair them. And now you realize that when you just write it for like hydrogen itself and oxygen itself, we have like one electron here for hydrogen that is like by itself. We call, so here, for oxygen, we have like 2 dots that are not paired, right? So here, I need another hydrogen here, right? And hydrogen has just 1 electron, right? So I need to put another electron here. So this electron and this electron, they form a bond, chemical bond. And then here, hydrogen and oxygen, again, these 2 form a bond. So what we put like some long dashes, I guess, or these lines between 2 electrons that are shared between molecules. And the reason, is this clear why did I put 2 hydrogen? Because I had like 2 single electrons for oxygen. And do you remember from previous sessions, I told you that except lithium and hydrogen, all other main group elements, they want to reach an octet. So they want to have 8 electrons in their valence shell because this is the most stable electron configuration. That's why noble gases are so stable. They're all set. They don't want to participate in any reactions or any chemical bonding. That's why we see Ne, neon, or like helium, He by themselves. We don't see Ne3, but we see O2, right? So here, so what you do, when I ask you in the exam that which of the following is the Lewis structure of H2O. So what you do is that you write, so you know from H2O that you have like 2 hydrogen, 1 oxygen, right? And then 1, 2, 3, 4, 5, 6, and try to have the electrons in a way that the ones that are like single, they are like single dots, you have them next to the atom that they want to form a chemical bond. And the reason is that, this hydrogen here has 1 electron, this one has 1 electron, and when you have 1 electron from one atom and 1 electron from the other atom, in covalent bonds, they share the both electrons and we kind of connect them together. Like this and this. So any of these 2 that you write, this or this, both are correct, So here in Lewis structure, but we just write the simplest one in Lewis model. So your book wrote this. So you just stick with that one too. And as we progress in the chapter, you see that H2O molecules are actually bent. So they are not straight. But Lewis model does not capture for that. We're just dealing with the electrons. So if I tell you now, this hydrogen, how many electrons it has now? So you count 1, 2. Right? So it has 2. And then the other hydrogen, this is the same alarm of my phone. Is it my phone? So, okay. So this is like this, for this hydrogen, if I ask you how many electrons it has right now, it's like 1, 2. And do you remember that hydrogen and lithium, they were exceptions, that they wouldn't reach octet, they would reach a duet. So having like 2 electrons in hydrogen makes it to have like 2 electrons which have like helium electron configuration, which is the most stable one for hydrogen. But if I ask you how many electrons oxygen has right now, so you say 1, 2, 3, 4, 5, 6, 7, 8. Now oxygen is an octet. So that's what sharing electrons means, right? So you should consider in the chemical bond, in each chemical bond, you have like 2 electrons, and then each atom shares those electrons. Is that clear what I just said? Are you comfortable with, drawing Lewis structures. So let's try another one. So if I tell you, first of all, what is CO2? What type of compound is it? Is it molecular, ionic, acid? What is it? It's a molecule, right? So now, for Cl, how many valence electrons Cl has? 7, right? Because it's in group 7A. You know, at this point, try to remember this because it helps you a lot. So group 1 is alkali metals, right? 1A. Group 1, 2, or like 2A, sorry, 1, 2. Group 2A, what is group 2A? Alkaline earth, right? What about group 7? What do we call them? Halogens, right? What about group 8A? Noble gases, right? I'm going to ask that in your exam, so just remember. I'll give you the periodic table too, but just, so what is the group 1B? What type of elements there are? They metals, non-metals, metalloids, the ones that have B, 1B to transition metals. So when you see like B, they are like transition metals. Okay, so now for like Cl, what I do is that I say, okay, 1, 2, 3, 4, 5, 6, 7. And then I write another Cl. And as I said, the one that is like by itself, just write it next to the other element. So 1, 2, 3, 4, 5, 6, 7. And then these two will form a covalent bond. Is that clear? Somehow how we do this? Okay, so now let's try to do that for O2, right? We breathe oxygen all the time. We might as well know how to draw its Lewis structure. So oxygen, how many valence electrons it has? 6, because it's group 6A, right? So what I do, I write 1, 2, 3, 4, 5, 6. So now let's have another oxygen. 1, 2, 3, oh, sorry. 1, 2, 3, 4, 5, 6. Is this clear so far? So far, so good. And now, you know, as you can see, we have like 2 of these single electrons. So one of these go here, one single electron from oxygen with the other, and then one here, single electron, the other one from the other oxygen. So to write this more organized, like your book, we write this as the bonds like this. And we call this a double bond. I guess I just have like the same shape or like the size, I guess. So this would be O2. And as I said, we call this double bond. So can anyone tell me what would be the definition of double bond based on what I wrote? So the previous one for Cl was single bond. This is double bond. Anyone? So we have 2 pairs of electrons shared between the atoms. We call that a double bond. I guess I write the definition for you too. So when 2 electron pairs are shared between 2 atoms, the resulting bond is a double bond. Is that clear? So you just pair the electrons. So one single electron from one element with the single electron from the other element. You pair them, and then you will be having a chemical bond. If you need to do that twice, you will be having double bond. And now if I tell you for this oxygen here, What is the total number of electrons? How many? 8, right? You see that you have like 1, 2, 3, 4, 5, 6, 7, 8. And remember, most of the time, we have exceptions that I'm going to talk about, but in most of the time, elements want to reach an octet to have like 8 electrons in their valence shell. And the other definition here is like bonding pair electrons and lone pair or non-bonding electrons. So these electrons that participate in a chemical bond, we call them bonding pair electrons because they participate in a chemical bond, right? And then these electrons, these ones, we call them lone pair or non-bonding electrons. So the ones that participate in a chemical bond, we call them bonding electrons. The ones that they don't participate, we call them non-bonding or lone pair electrons. Is that clear? Okay, so something to know about double bonds is that because, if you go measure the bond distance between single bonds and double bonds, you see that double bonds are like shorter. And the reason is that, you have like, 4 electrons here. So because of the, interactions between these electrons, right? And then the other quantum mechanical effects that we're not talking about this course, in general, double bonds are like shorter and they are stronger than single bonds. And this is something, I wrote in your study guides, I asked you in your practice exams, and it's really important to just remember that double bonds are like shorter and stronger. I wrote that in your study guide too, so don't worry about that. And now let's do another example. What about N2? How many valence electrons nitrogen has? 5, right? So when you want to write this for nitrogen, 1, 2, 3, 4, 5. And I do for the other So here you have like 3 electrons, and then I do that again. 1, 2, 3, 4, 5. And now, as I said, one single electron from one atom with the single electron from the other atom. So now this electron with this electron, this electron with this electron, this electron with the other one. So now you will be having, and again, the better way of writing this is like this. We call this a triple bond. And then, as you may guess, when like 3 pairs of electrons are shared between the elements in a chemical bond, we call them triple bonds. Is that clear? So triple bonds are also shorter than double bonds and single bonds, and they're also stronger. Any question about anything so far? So as I said, remember, so triple bonds are even shorter and stronger than double bonds. And the same thing applies for double bonds. Like double bonds are shorter and stronger than single bonds. So if I tell you, which one of the following has the strongest bond, right? So would it be triple bonds, single bonds, or double bonds? Triple bonds, right? So just remember that. Okay. So any question about triple bonds, single bonds? So as I said, I'm going to write all the structures that I expect you to know in this study guide. So just study those and ask me questions if you have. Okay, so now let's do another thing. So now if I ask you to write electronic structure for one of your polyatomic ions, for instance Cn minus. So it may seem scary, but it's not. It's just what we did earlier. So how many valence electrons carbon has? Why 4, 5? Just for carbon. 4, right? So, I mean, probably you looked at this minus and then add 1, but just don't worry about it right now. Just for carbon, we have like 4. And what we do is that we put 1, 2, 3, 4. What about nitrogen? How many nitrogen has? 1, 2, 3, 4, 5. Right? And now, as you may guess, here we have like 1 electron. And then you see, it's kind of like, you should like just do practice to know how efficiently to do this. But if you just look at here, you see like, okay, I can probably pair this electron with this electron, this electron with this electron with this. And now I have 1 more electron right here, because Cn minus means that Cn got 1 more electron, right? Can I put it next to nitrogen anywhere? Yes or no? Why? Exactly. If you count this, nitrogen has like 6 electrons for a triple bond and 2 for lone pair electrons. It has already 8. It cannot exceed 8, right? But here, carbon, how many carbon has electrons? How many electrons carbon has? 7. So I can put this electron here, right? And the whole thing has the charge of -1. So this is how you write the Lewis structure of Cn minus. Basically, this is like more neat version of writing that. Is that clear? So you counted the number of valence electrons for carbon and nitrogen and added this charge to it, right? Let's do another example. So for NH4 plus ammonium, and do you remember this was the exception I told you that ionic compounds are mostly metals plus non-metals, except ammonium that is not a metal, but it still can form an ionic compound, right? So for this, again, we write like nitrogen, 1, 2, 3, 4. How many valence electrons it has? 5, right? And then let's write for hydrogen. 1, it has only 1, right? Or I guess I just write this hydrogen a little further. Hydrogen here. So now NH4 plus, it means that NH4 has lost an electron. So here I can pair these guys without any difficulty, but which one can lose an electron right now? Right, because I form a bond here, and then this one would be like for NH4 plus, right? So here I just erase this extra electron here, and then I put the charge. So this would be the Lewis structure for NH4 plus. Is that clear? So when we write the Lewis structures, for some elements like NO, if I want to write the Lewis structure, I would like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. And then when I come to like pair these, it doesn't work out, right? So it tells us that Lewis model is not perfect. As we said, it's really simple model to predict the structures of the, covalent bonds, and also like, in general molecular compounds and ionic compounds, but it's not perfect. It has exceptions. These are exceptions to the octet rule. NOBF3, BH3, PCl5, SF6. And then your book, let me see if I can do this. Okay, so your book has like their structures here. So here we talked about, nitrogen, it has a single electron. Here it doesn't reach octet. Or here, boron, it doesn't reach octet. Or here, for instance, for like, we have like 1, 2, 3, 4, 5, 6. We have like 12 electrons for like sulfur, right? So these are just like, remember that, this model is like really simple and it's not perfect and it has exceptions. And then in the exam, I tell you which one of the following is not an exception of, Lewis model, or like which one is an exception. As long as, you know how to write Lewis structures, or like just remember the exceptions, you should be able to identify the corresponding question, right? Okay, so now that I have like 2 more minutes, and I appreciate you guys' patience with me, I just go to the quiz, or not quiz, the practice exam. So I really appreciate just putting my old name. Okay. Oh. Huh. Yes, just give me 1 minute and I turn off this light. Okay. PC. Okay, just because I made sure to write the makeup practice exam, it took me like hours to do that. Just wanted to make sure that I'd be able to show it to you guys during the class. So I appreciate all of you guys' patience. Okay, so here I go. Oh, okay, so here's the thing. I just show link. Okay, so that was it. So now I go to student preview. So now, if you just have some patience, I'll answer. Oh, okay, some questions too. Okay, so let me exit preview. Let's come here. So what did I do? Exit, edit this test. Let me do that again. Okay, edit this test, edit test options. Okay, so these are like tools, assessment, building content. Okay, make available. Okay, that was the thing. Okay, let me see if I can make sure, and then as I said, if you guys wait, I'll answer some questions for you. Huh. Now it should do, I guess. Now I'm in the student preview. So now so now it should be good. Now I'm in student preview and I can see. So it says, and then you see the questions randomly. So which of the following is not an exception to the octet rule? So we just talked about that. So can anyone tell just based on, or I guess I can just switch between these two. So here I wrote the exceptions to the octet rule. NOBF3, BH3, PCl5, SF6, right? And now it's kind of like coincidental that just it showed me the same thing that I just talked about. So it's a fate. Which of the following is not an exception to the octet rule? NOBF3, NH3, SF6. Exactly. So here we go to the next question. Which of the following represents Thomson model of atoms? So he theorized, and okay, I have a typo here too. So remember, when you read the questions, also try to understand the other answers, because I asked, I just changed the question a little. So can anyone tell me who theorized that atoms are indestructible particles? Who? Yes. So before that, we said that Greek philosophers like Democritus also said that, but John Dalton, it wasn't until him that they agreed with this. So he theorized that negatively charged electrons were small particles held within a positively charged sphere. Who said that? Thomson, right? So this is the answer. He theorized there are many negatively charged electrons outside the nucleus, as there are positively charged particles, protons, inside the nucleus. Can anyone tell me who said this one? Who? Rutherford, yes. Rutherford, yes. He theorized that electrons travel around the nucleus in circular orbits that are similar to planetary orbits around the sun. Exactly. So now you answer this, and then go to the next questions. And then, which one has the highest frequency, and then all questions. So I would, kind of like stay with you longer, answer the questions, but your class time is over. So I just wish you the best for your final exam. And as I said in the announcement, I had really fun teaching you all, and I tried my best to do well. So hopefully you all get a really good grade in this course, and then feel free to stop by next week at my office. Email me if you need more office hours. This is something that I meant to talk about, but I forgot. So if you need more office hours, just email me. I schedule more office hours for you, and I'll try to be at my office next week for the majority of time to answer all your questions. And then feel free to just stop by my office next week to pick up your makeup exams, or like your quizzes, solutions, anything that you need to study for your final exam. Okay, thank you all. Thank you.
I just wanted to know, we don't have class next week, right?
No.
And then what are your off hours at the usual time, like right after this class?
Yes, but I'll try to have more
Okay,
for
thank you.
next week, yeah.